Hello everyone, and welcome to the fourth video in this series on rendering graphs in Grafana. If you haven't watched the first three videos yet, I highly recommend doing so, especially the previous one, the third video in the series. In the previous video, we covered the general use of expressions in Grafana. We focused on the Resample expression, examined the new time windows it creates using a new data object, and discussed both upsampling and downsampling, including when to use each one. We also covered several edge cases related to using Resample. In today's video, I'll demonstrate a practical example of using Resample. First, let's introduce the data sources we'll be working with. Both data sources will be displayed on the same graph. At the moment, we're only seeing the line from one of them. After I explain it, we'll add the second one as well. Why did I choose two different data sources for this demonstration? Because they make it easier to illustrate the concept I'm trying to explain in this video. We're using mixed mode, which allows us to include more than one data source in the same panel. The first data source is Prometheus. The query shown lets me monitor my CPU utilization. The underlying metric is a counter, and we're applying the irate function to calculate the rate of change. In the query options, you can also see that I've set the interval to 15 seconds. You can verify this by following the data points on the graph. Now I'll scroll down a bit to reveal the second data source, which is PostgreSQL. It contains a simple query that retrieves data from a database. Notice that the PostgreSQL query is currently set to hidden, so its line isn't being displayed. We'll make it visible in a moment. But first, I'd like to briefly show you what's actually stored in the database. So let's switch over to the database for a moment. The table you're looking at is a dedicated table that I created specifically for this demonstration. It stores the number of active connections to my database. There's a script that writes a new record to this table every 2 minutes. The table has two columns. The first is the timestamp, and the second is the number of database connections. Notice that the interval between records is approximately 2 minutes, but not exactly 2 minutes. That's because the script is executed by the task scheduler, which reads the data and then writes it to the table. As a result, the execution time isn't precise down to the second. Now let's go back to Grafana. As we saw, the PostgreSQL data source contains a query that retrieves this data. Let's unhide the PostgreSQL query so its line is displayed as well. Now you can see both data series on the graph. The data coming from the Prometheus data source and the data coming from the PostgreSQL data source. Displaying both data series on the same graph can be very useful when you want to examine the relationship between the number of database connections and the CPU utilization of the database server. As you can see, the spacing between the data points on the PostgreSQL line is approximately 2 minutes, which matches the way the data is stored in the database. And of course, the two lines are not aligned. The Prometheus data is displayed at a 15-second interval, which is the interval we've configured. In contrast, the PostgreSQL line is plotted using the timestamp stored in the database, so the points are roughly 2 minutes apart. Now let's apply what we learned in the previous video and align the PostgreSQL time grid to a 15-second interval as well. This will, of course, produce interpolated data rather than actual measurements. However, it provides an estimate that's as close as possible to the real values, and that's more than sufficient for the purpose of this demonstration. So let's define a Resample expression. We'll set it to 15 seconds. I want to remind you that downsample is not relevant in our case. What matters here is upsample, because we want to add more data points to the line. Instead of having 1 point every 2 minutes, we want to have 1 point every 15 seconds. Let's take a look at the result. I want to remind you that Resample creates a new data structure. It does not overwrite the original one. So we'll hide the original query. We'll zoom in on the data. And this is the result. Notice that the intervals between the points have indeed become 15 seconds, which is exactly what we were looking for. However, we have another problem. There is no alignment on the time axis between the points on the Prometheus line and the SQL line, which is represented by the Resample expression. For example, on the Prometheus line, We have a data point at 2036, but we don't have a corresponding point at exactly the same timestamp on the Resample line. We do have nearby points a few seconds before or after, but not the exact same timestamp. Beyond the visual inconsistency that we can see in the graph, there's another issue. Let's say we want to create a math expression using these two lines, the Prometheus line and the sequel line. We won't be able to do that successfully. I'll demonstrate what I mean in a moment. But before the demonstration, I want to emphasize that using a math expression in this example does not have any real practical meaning. I chose this example arbitrarily, only to illustrate the point. Let's select a math expression. In the expression, I want to add the result of the Prometheus query together with the Resample line. Again, this operation has no real meaning. It is only for demonstration purposes. But after refreshing, we don't get any result. The reason is the time difference between the points on the Prometheus line and the points on the Resample line. Even though the points on both lines are now 15 seconds apart in terms of the interval between points, what ultimately causes the problem is that their positions on the x-axis do not match exactly. So how do we solve this? By using a time picker. Let's make the change. This is the syntax. Notice that in our case, I selected a resolution of minutes. If you change the time resolution to something else, for example, days or months, you will need to adjust the time picker accordingly to match your requirements. This is the result on the graph. And as you can see, because the points from both lines, the Prometheus line and the sequel Resample line, are now aligned, the math expression produces the expected result. Of course, the actual result has no real meaning, but it allows me to demonstrate the point I wanted to make, how to completely eliminate the time gaps between two data series. Thanks for watching.